Today we're going to find the volume for when we do a solid of revolution. And so you got to remember back with the lemons, we found out that if we cut a very thin slice, then we would get a shape that was like a cylinder. So with calculus, what we're going to do is we're going to cut them up into teeny tiny cylinders, and then we're going to add all those cylinders up. So we got to find the volume of a cylinder, which is the area of the base times the height. And when it's a cylinder, the base is a circle. So it's pi times radius squared times height. We call this the disk method. Each little cylinder is considered a disk. And so what we're going to do is we're going to use the function value as the radius, and we're going to use the width as the height of the cylinder. And so y is the radius and dx is the height. So this is our first example, and we're going to go from 0 to 4, and we're going to revolve that around the x-axis. So you can see my lovely artwork here that we always sketch the graph and what it looks like when we revolve it around the x-axis. Notice I did not use the entire graph y equals x squared. That's not necessary since I only went from 0 to 4. That's the only part that I put on there. When you make a sketch, you have the whole solid, and then somewhere in the middle you're going to do a little part. We call that a slice. That is the representation of just one disc or just one cylinder. Now I think that graph looks a little bit like the bell of a trumpet, but if you really can't visualize it, then you need to do a search for solid of revolution images and find some animations. They help some too. When we do these, we can ignore pi until the end, and remember that you're going to square the radius, so be sure to do the algebra of that. We are calculating volume when we're not given a label, so it is units cubed. Remember, it's pi times the radius squared times height, and the radius is y. So we plug that square root in there, and then the squared cancels it out, so it makes it so much easier.